problem is from Irodov problem number 1.153 part A. In this problem, two blocks of mass m are connected through a spring of spring constant k and upper block is compressed by delta. Now a thread is connected through two blocks. The thread is snapped. We have to find the value of delta for which the lower block gets lifted up. Okay, now let's see the situation when the thread is snapped. In that case, since there is compression in the spring, when the thread is snapped, the upper block will rise, and it will rise and reaches the equilibrium position where no elongation or compression in the spring is there. And afterwards, what will happen? There will be elongation in the spring, and let's say here x is the elongation in the spring. Then as x increases, so kx is the force exerted by spring on the lower block in upward direction, and kx mg at any instant, and normal reaction force will be there. As x increases, normal reaction force will decrease. So at a certain value of x, this normal reaction force is going to be 0, and then kx must be equal to mg at this instant. And at this instant, its velocity is also equal to 0. Now the upper block might have some velocity v, let us say. Now apply work energy theorem for these two blocks. We have work done by the gravity acting on the upper block, and plus work done by spring, and this must be equal to change in kinetic energy of the system, and the work done by gravity will be mg times delta plus x with a negative sign because displacement is in opposite direction to gravity, and work done by spring is minus half k x final square, which is x square, minus x initial square, which is delta square, and this is equal to change in kinetic energy. Final kinetic energy is half mv square, that is of the upper block, and initial kinetic energy is 0. So we have this equation, and also plug the value of x from this equation mg by k, plug this value and solve this equation. Also, we have minus mg times delta plus x minus half k times x square minus delta square is equal to half mv square, and this value is the kinetic energy which is greater than equal to 0. Now we can also say mg times delta plus x plus k by 2 times x square minus delta square is less than equal to 0. We have multiplied by minus 1 both sides, and take delta plus x as common. It becomes mg plus k over 2. X square minus delta square is x plus delta into x minus delta, which I have taken x plus delta is common, and that is less than equal to 0. Plug this value here and we get the value of delta, and this delta comes out to be greater than equal to 3 mg over k, and that's the final answer.